Hello everyone. I'm going to show you now how you can use Excel to do the method of joins for the analysis of traces. It's not that we are going to do equation by equation using Excel and putting the little calculations on Excel. We are going to use a matricial form of the problem, which is set up the metrics of all the coefficients of all the equations in just one big package and put all that matrix of equations in Excel. Excel will do the inverse, and then we that way we solve the problem in one chat. The advantage of this is that first, you don't have to calculate the reactions before you start. Like usually they tell you should do the free body diagram of the whole structure to find the reactions. And you know that in the method of the joints, you don't need to do it necessarily. Sometimes you have to, sometimes you don't. In this case, you just don't have to. And you don't have to go joint by joint looking for which joints have less than two or less unknowns in order to continue. Here you just set up all the equations, no matter how many unknowns they have. You just put all of them, so you can go in order like alphabetical order or any order that you want. You just set up all the equations, and you concentrate on do the free body diagram of each joint. Set up the equations very nicely. You do it in a very orderly fashion. Alphabetical order will be like the best. And then once you have all the equations, we put all the coefficients in Excel, and Excel solves the system of equations for us. Let's get started. I have this example on the screen. Before you start, it's good to have a free body diagram of the whole structure. This is the free body. This is the free body diagram of the whole structure. It's also important to have the angles that you're going to need well defined. We have the angles here, alpha and beta. Alpha will be defined as tangent minus 1 of this distance, which is 12, over this distance, which is 5 plus 11, 16. So will be 12 over 16. And beta will be tangent minus 1 of beta will be, again, if we look at this triangle here, so the same 12 over this little side here, which is 5. 12 over 5. So those are the angles that we need in order to do all the calculations. That will be enough. And those are all the bars, and the free body diagram also is showing the reactions. So we just have to set up one by one all the equations, starting by joint A. So let's start by joint A. Free body diagram of joint A will be here. This will be free body diagram of joint A. Elements AB, AD, AC. You see it here. I'm not going to explain too much, as you guys know already this method. It was well explained in the previous video. We just go over setting up the equations. Basically, I will put the equations right there. And so summation of forces in the x direction, AB, AC cosine alpha minus AD cosine beta. Summation of forces in the y direction, not a problem for anybody here. Only two forces, AD and AC, have component in the y direction. Now we go to joint B. Joint B, summation of forces in the x direction, positive to the right. So BE is positive, the other two are negative. summation of forces in the y direction. Actually, in this equation, we are going to move this term to the other side of the equation. So we will have here, instead of 0 here, we will have minus 693, and that will be like the right hand side of the equation. So this will go to the other side with negative. Go for joint C. Joint C, all the angles are alpha. This angle is also alpha, alpha, alpha. Summation of forces in the x direction. Summation of forces in the y direction. Joint D. Summation of forces in the x direction. Summation of forces in the y direction. Joint E. Summation of forces in the x direction. And summation of forces in the y direction. So we have all the equations. You guys can stop the video later if you want to review these equations. Make sure you understand everything. So, but your concentration has to be on doing nice free body diagrams of the joints and get all the equations, including the reactions. You guys see the reaction here, the reaction here, reaction here, reaction here. All the equations include all the unknowns. So now we need to put this in Excel. First, we have to set up the angles. Let's open Excel. Let's set up the angles. Let's call them alpha and beta. Alpha, beta. Alpha will be arctangent of 12/16. Beta will be arctangent of 12/5. And then I'm gonna give names to this so I can work with names. Formulas, create from selection, left column, okay. And now I'm gonna create some variables for sines and cosines of these two. I'm gonna call sine alpha, sine A, sine cosine A, sine B, cosine B. Those are variables that I am creating to contain the sine and cosine of alpha and beta. So this one will be sine of alpha. So this will be equal sine of alpha. This one will be cosine of alpha equals cosine of alpha. This one will be sine of beta. And this will be cosine of beta. Cosine of beta. Be aware that Excel works the angles in radians. So this number that you see here, this 0.6 is the arctangent of 12/16 in radians. And then here, when I calculate the sine and the cosine, is taking this value in radians directly. Excel works by default. Excel works all those angles in radians. So now I'm going to create these variables here, sine A, cosine A, sine B, cosine B, in order to work with names, not with the reference D1, D2, D3, which is much more confusing. So I create the names, create from selection, left column. Now I can refer to those as sine A, cosine A. Okay, so now let's make a list of all the bars. All the bars, including the reactions. So here will be all the bars AB, AC, AD, BC, BE, CD, CE, and the reactions dx, dy, and I am missing one reaction here. I am missing the reaction EY. Okay, so we have, this is better. All the bars, all the reactions. I'm gonna put all these names on top here, on top of where I'm going to fill up this matrix. Let's put it here. Paste special transpose. Okay, so here in this area, I'm gonna put all the coefficients for all the equations. Say, for example, in starting for the equation on joint A, this first equation here has only 3 unknowns, AB, AC, and AD. So this will be the equation, but many of those cells will be filled with 0 because only 3 variables have coefficient there. And then the right hand side of the equation is 0 also. So I'm gonna fill all this region here with zeros because many of those will be zeros. So I don't have to type all those zeros here. So let's put 0, 0. Let's center all those numbers. Okay, so let's start by filling out the first equation, this one right here. AB is multiplied by 1. So here I'm going to put a 1. Then AC is multiplied by cosine alpha. So here I will put cosine alpha. So I go equals cos A. That's the variable that I created for cosine alpha. Then AD is multiplied by minus cosine beta. So I come here to AD and type equals minus cos B. Cos B is cosine beta. Is this 0.38 that I have here? So it's here. So I have this equation ready. All the other terms are 0, and the right hand side of the equation is also 0. This is the right hand side of the equation. Let's put some border here. Okay, so now we go for the second equation. AC sine alpha, AC sine alpha. So this is AC here equals sine alpha 0.6. And AD sine beta. AD is this column here. So here it will be sine beta equals sine beta. All right, and no more elements, so everything's 0. Next, join B. We have this equation here. BE cosine beta. BE cosine beta. Cosine beta. BE cosine beta minus cosine alpha. BC minus cosine alpha. BC is this one right here equals minus cosine alpha. Cosine alpha. Cosine beta, cosine alpha, and then minus AB. AB multiplied by minus 1. AB multiplied by minus 1. AB multiplied by minus 1. Next equation, this one right here, BE sine beta. BE sine beta equals sine beta. BC sine alpha. BC equals here equals sine alpha. And then and the right hand side of the equation minus 693. So here minus 613. Minus 693. Minus 693. Next equation, join C. BC cosine alpha. BC here. This is BC. So BC cosine alpha equals cosine alpha. Then CE cosine alpha. Oh, actually, here, all these terms are multiplied by alpha, cosine alpha, and all this by sine alpha. Actually, we can simplify all those by dividing everything by cosine alpha, and here sine alpha. So we just have a coefficient of 1 for all those terms. So that makes things a little easier. Right? So that would be BC was cosine alpha here, so actually it's going to be a 1. Then CE, where is CE? A 1. And then AC minus 1, AC minus 1, and CD minus 1, CD minus 1. CD minus 1. Now, this equation, BC times 1, BC 1. CE minus 1, CE minus 1, C minus 1. AC plus 1, AC plus 1. And CD minus 1, CD minus 1. CD minus, okay, ready that one. Equals to 0 here. Now, join D. CD cosine alpha. CD cosine alpha equals cosine alpha. AD cosine beta. AD cosine beta equals cosine beta. No negative elements over there. And then dx 1. dx multiplied by 1. And equals to 0. Then CD sine alpha. CD sine alpha equals sine alpha. AD sine beta. AD sine beta equals sine beta. Plus dy times 1. dy times 1. Now, next, join E, BE cosine beta, BE cosine beta equals cosine beta. CE cosine alpha, CE cosine alpha. And then equals to 0. And then the last one, BE sine beta, BE sine beta equals sine beta. C sine alpha, CE sine alpha equals sine alpha. And then that was C sine alpha, and then EY times 1, and 0 on the other hand, on the other side of the equation. Actually, this is an unequal. Unequal sign here. Okay, so all the questions seem ready. Hold on 1 second. All right, so we have all the metrics of the coefficients complete. Now we need to, let me increase this a little so we work better. So we need to take the inverse of this matrix and multiply by this vector. Let's put it here. In order to do this in Excel, and let's put a copy of the unknowns here. This is how you proceed. In newer versions of Excel, it's kind of easier. In older versions of Excel, if you have an older version, you have to select the area of the inverse matrix. We are going to take the inverse of this matrix here, and we're going to put it here. So you select the whole area and you start typing on the right, on the first corner, on the top left, and you type equals M inverse, open parenthesis, and then you select the whole matrix. And before you press anything, well, you close the parenthesis, and before you touch anything, you just press Control Shift Enter, Control Shift Enter, and the whole matrix is full with the inverse. Let me repeat that. You select the whole area, make sure you select an area that is equal to the original matrix, and without doing click on the mouse with anywhere, you just select and don't click anything. You just start typing equals M inverse, open parenthesis, select the original matrix, close your parenthesis, and press Control Shift Enter. That's for older versions of Excel. In Excel 365, you just type M inverse parenthesis, select the matrix, and just press enter, and doesn't even need to press to close the parenthesis. It's much more smart. It's smarter. So now you have the inverse. So now you need to multiply this times this, and the result we're going to put it here. Let's put the result in here. Those are gonna be that's gonna be the solution right here. So you just place the cursor right there. In older version of Excel, you select the whole area and start typing if you come here and select here to start typing, you screw it. You have to select and start typing equals M mult, select the first matrix that you're going to multiply, comma, select the vector, close parenthesis, and then Control Shift Enter, and then you have the solution. That's the solution to your problem. That easy. Let's take a look a little bit to what we got right there. For example, we have to check. We can check here equilibrium of the whole structure. You have 693 going down, so dy plus ey has to add up to 693. Let's see. You make the summation of dy plus ey. Let's do here equals of dy plus ey equals 693. So it checks equilibrium in the y direction. In the x direction, dx is the only force in the horizontal direction here, so dx has to be 0. Dx has to be 0. Okay. So at least those external forces add up to equilibrium, so it looks pretty okay. We should maybe make another check if you take like one of the nodes to make sure that it's in equilibrium, and it should be all right. You have always you have to check your work always somehow. Take one joint at random and check the equation of equilibrium. Make sure that add up to 0 in the x and in the y direction, and that should do it. Okay, so that's the way to do it with Excel in one shot. All the calculations are done by Excel. You just have to concentrate in doing nice diagrams, very organized equations like we have here, and be very careful. It's very easy to make mistakes in this method of the joints because it has so many details. All right. Thank you very much for watching. Bye-bye.